Hello and welcome to this tutorial. We are going to talk about the TCP IP model. Now this is one of two great blueprints or roadmaps to computing. The other model, which is known as the OSI model, is talked about in detail in a separate tutorial. So we're going to focus on just this one model today, and really the TCP IP model is an architectural model. It's going to explain how things work. Specifically, it's going to give us insight into how the different aspects of computing work not only within a particular device, like a computer or a router, but also between devices, like two computers interacting with each other. So we'll be able to fit the different puzzle pieces of how a particular operation works by using this model. So for instance, if I were to ask you, what exactly happens in detail after you hit the send button on an email? Well, there are a lot of different small steps and processes involved, and by using this model, we can go ahead and put together a full picture with a lot of detail. Now keep in mind, this model is not arbitrary. In fact, it defines industry standards. Standards are defined based on this model, so everyone using it has a similar point of reference. That means colleagues discussing a particular problem or vendors making different types of equipment are all on the same page. Ultimately, that means things work together because we're all using the same blueprint. Alright, so the TCP IP model, TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. Now the model itself, TCP IP, is actually an umbrella of protocols. It's a name of a group of protocols. This model is just choosing these two particular protocols within that umbrella as the name. So it might be a little bit confusing, the TCP IP model, but then TCP is a protocol, IP is a protocol. Don't get too confused by the naming convention, okay? So we're going to go ahead and take a look at this model, but specifically we're going to look at all four layers of it. So that's the first thing to know. This model is made up of 4 different layers, and when we go through all the layers, what each one does and how they interact with each other, we'll finish by looking at the benefits of using this model. Alright, so let's get started with the first layer in this model, which is the application layer. Well, in fact, let's take a look at all the layers before we begin. And here we have not only the application layer, but the transport layer, the internet layer, and finally the network access layer. These are the 4 layers of the TCP IP model. And when you're studying this model, not only do you have to know the names of each one and what each one does, but the order is very important as well. So keep this in mind. The application layer starts at the top of the model, and they are ordered just as you see them, transport, internet, and at the bottom is the network access. Now this ordering is going to make more sense to you as we learn about each one and how they interact with each other, but just keep this in mind when you're studying. To the right-hand side of each layer, we listed a few protocols that are associated with each layer, just to give you an introductory sense or feel that each layer is really different from one another. At the application layer, we have protocols such as HTTP and DNS, transport is TCP and UDP, the internet layer is IP, and then an example of the network access layer is Ethernet. Okay, so have a general sense of these protocols relating to each one of these particular layers of this model. And with keeping all this in mind, let's move on and take a look at the details of the application layer. So the application layer defines how programs should behave. You can probably kind of guess that from the name itself and as we've indicated, how a program acts when it runs on a particular device, and also what are its responsibilities when it runs on a particular device. Those things are defined at the application layer. Now the application layer also defines how a program will interact with the other layers of the TCP IP model. So each layer has to interact with the layer above it and the layer below it. Now for the application layer, since it's at the top, there's nothing above it to interact with. So the application layer has to interact with the transport layer, and it does so by sending it information. Another thing to note here is that each layer services the layer above it. So the transport layer is considered a layer that services the application layer. Even though the application layer doesn't have a layer above it to service, it still has to interact with the transport layer. And this behavior goes all the way down the stack. So the transport layer has to interact with the internet layer, and the internet layer is considered the layer that supports or services the transport layer. And that also holds true going all the way down to the network access layer and it servicing the internet layer. Now, the application layer doesn't actually define programs themselves. You don't actually see a definition on a particular program you like to run, and that could mean a game, a web browser, or an email client. Okay, so don't confuse the two. It states how programs should behave, but it doesn't actually define what the programs are. And lastly, there are many applications, way too many to list. But basically, we can say this: whatever you consider to be a program that's running on your computer, like some software you buy, like a game I mentioned, or an email client, those are considered to be applications, programs. All right, so let's move on now from the application layer. We'll take one step down into the transport layer. Now, it's at the transport layer where we're concerned with how data is actually delivered. So at the application layer, you have a program running, it generates some data, it needs to send it to another computer. So then the transport layer gets involved, and here we start to come up with ideas and methods on how to actually deliver that data. Now specifically, there are two protocols associated with the transport layer. There's TCP, which stands for Transmission Control Protocol, and UDP, which stands for User Datagram Protocol. We cover the details of both of these in a separate tutorial, but we'll give you an introduction for now. TCP is concerned with guaranteeing delivery of information. So this is considered a connection-oriented protocol. In other words, it establishes a connection first, and then it guarantees that once that connection is established, two different devices can exchange information, and it guarantees delivery. Not only that, TCP is involved with error recovery. So if one of those packets is lost along the way, TCP has mechanisms to go ahead and make sure that the data is retransmitted. Now, UDP, on the other hand, stands for User Datagram Protocol, and it is not concerned with guaranteed delivery. In fact, it does not guarantee delivery of packets at all. Also, it does not have any form of error recovery. So if a few packets are lost, UDP doesn't care. Now that may seem kind of silly, but really the purpose is UDP is designed for really fast delivery of information with a lot less overhead. There's a lot fewer mechanisms running in UDP as compared to TCP, because you're not dealing with all these other features like guaranteed delivery and error recovery. So it's suited for data that has to get somewhere really quickly. And a good example of that is like a media stream or a voice over IP phone call. Okay, so for now, keep in mind that these two protocols are the transport layer, and the transport layer is concerned with getting data from the source to the destination. Now, related to this concept of delivering data is the internet layer. So let's take another step down in the model and take a look at the details of that layer next. Now, the internet layer has one protocol associated with it more often than any other one, and that is IP, the Internet Protocol. It is the protocol of the internet and is probably the most widely deployed protocols in the world. So keep IP in mind when you associate protocols with the internet layer. And so the internet layer is concerned with end-to-end delivery of data. And it does this by using addresses. So it's at the internet layer and IP where we get logical addressing. Now this comes in the form of IP addressing. And you might have heard of that, and we have a lot of tutorials dedicated to explaining how IP addressing works. So it's at the internet layer and IP where IP addressing comes into play. So in order to get a packet from one IP address to another, we have to route it there. And it's also at IP where the routing of data is defined. So at the internet layer, we deal with not only IP addressing, but the actual routing of data between the different IP addresses, between the different devices. All right, and one thing similar that we mentioned earlier, but is worth repeating, each layer interacts with the layer below it and services the layer above it. So just to reiterate, there's no difference here when we talk about the internet layer. It not only sends information down to the network access layer, but it also services information that it receives from the transport layer. Okay, so we've got one more layer to go, the network access layer. Let's take a look at that one next. All right, well, we've made it to the bottom of the TCP IP model, and here we find the network access layer. And so at the network access layer, we're concerned with the immediate physical network. So remember, with the internet layer, we said we're concerned with end-to-end logical delivery of information. Well, between these two devices, there are many different points within a network. The network access layer is concerned with the immediate segments, or all the little segments between these two devices, and every device along the way uses the network access layer to interact with the physical network it's connected to. Okay, so at the network access layer, things like hardware, the different types of connections, the different protocols used, and how data is transmitted from one hop to the next, quite literally. Now, a good example of a protocol at the network access layer is Ethernet. And we talk a lot about Ethernet when we talk about local area networks. And finally, why do we need this model? Why do we need to know about the different layers? Well, there are many advantages to using a model like this. First, it allows different vendors who make the same type of equipment, so different types of routers from different vendors, say Cisco and Juniper, well, they can make devices that will work together because they're following the same blueprint. And that's really important. As a consumer, now you have many different options to buy when you're going to put together a network. You're not locked into one different vendor. Not only that, but different networks between different companies can now interact and work because the equipment is based on the same blueprints. That means we're creating industry standards, and these standards are adhered to by everybody, and they're enforced by everybody. This makes life a lot easier. Also, using a model like this, we're dividing a rather big and complicated process of communications and computing in general into more easily understood, smaller components. So when we talked about sending that email after you hit the send button, we can now talk about the application itself, the program that you're using to send email. We can then talk about how it's delivered. Is it going to be a guaranteed delivery or not? And then we can also keep going, and we can talk about separately the addressing and the routing involved, or how it was actually put onto the network by the network access layer. So we can break down a very complicated process into little modules, and that benefits everybody because there's a lot of information at each one. Finally, for the same reasons, these different layers make development much easier. I can run a company that only specializes in programs, and I can make changes at just the application layer to something I've created. Or I can work on developing something specifically at the network access layer or the internet layer. And I can do this without interrupting all of the other layers. So in terms of development, we have a lot more flexibility and approaches to creating things and improving things while not being disruptive. Okay, so those are the advantages of using this model. And congratulations, you've made it to the end of this tutorial. Let's summarize what we've covered. We now know there are 4 layers of the TCP/IP model: the application, the transport, the internet, and the network access layer. Each layer does something unique and different, and each layer has to interact with the layer above it and below it. Not only that, we know that there are unique protocols associated with each layer, and make sure you keep some of those in mind. Finally, we know that there are a lot of benefits to using this type of model, and also, there again, commit some of those benefits to memory and make sure that they actually make sense to you when you think about using a model to interpret a very complicated process like computing. Okay, so that's it. That is the TCP/IP model. Thanks for watching.